All right, let's get started. My name is Paul Craig, and I'm part of the Coding BMB PyBMB team, and we'll be hosting the workshop today and on Thursday. And I'm going to provide a little bit of background here. I'm going to leave the poll open for a few more minutes. So, well, if you could keep an eye and let people in as they appear, I'm assuming we'll get a few more folks showing up. I'm going to share my screen. Okay. And are you seeing the slideshow or the teacher's version of the slideshow?
Slideshow, but it's got a little button on it.
Oh, continue to share. Great. All right, so welcome to our workshop. Our project is about computational literacy in biochemistry and molecular biology. And our team, we call ourselves PyBMB or Coding BMB, depending on the situation. The members of the team are Chris Berndsen from James Madison University, Mike Foster from Penn State University, Wally Novak from Wabash College, and myself from RIT. And just to get a little orientation about who we are all experts at biochemistry and molecular biology. Most of us have PhDs in that field or are studying toward in that direction. We are effective instructors in our classrooms. We work well with our research students. We care about the success of our students and of our peers. We are not experts at coding. We are not experts at teaching our students to code. Learning can be a humbling process. And my overall perspective on this is it's time to relax. Okay? Today we'll be learning some things. It's probably going to go, I think everybody in the room is going to find out at some point things are going a little faster than they wish they were. So we'll see how we can best handle that. This is just a little bit of what's going to be happening today. Mike Foster is going to give us a background on the pedagogical basis of coding, and then Wally Novak is going to introduce GitHub basics and forking repositories. Then Chris Berndsen is going to talk about Colab and Google Drive. We'll take a break. I'll come back and go over some basics of Python syntax. Then another break, and then Chris Berndsen is going to talk about pandas and plotting. And then we'll have a wrap up and a discussion of overnight tasks to do before Thursday. And then we've got more stuff happening on Friday. We'll be talking about opportunities to look at things. Wally's going to spend some time going over another notebook on linear regression. Could one of you guys paste the link for the GitHub site into the chat so people can click on that and download that? And then we'll have a break, and then Chris is going to come back and talk about using AI and how using Gemini in Colab works. Then we've got 4 different options. We have one session called Colab and Python Basics. So if you're going through this stuff today and you feel like this is way too fast for me, then this is probably the session for you on Thursday, and you'll have some time in that session. There's also going to be more in-depth study on the linear regression. I'll be leading Chris. Actually, Chris and Wally and I are going to be kind of migrating through all 3 of these other sessions. One's going to be on enzyme kinetics and nonlinear regression. One's going to be on using BioPython to do sequence analysis. And then finally, we have a sharing session where people can talk about what you're doing and what happened. And we'll have breakout rooms for each of those 4 topics. And then finally, we'll talk about resources and the next steps, and we'll have a closing at 3:50 on Thursday. We will have a post-workshop survey. The data you give means a lot to us, and it means a lot to NSF, who's funding us. So we would really appreciate you participating in that. That feedback helps us to improve our future workshops, helps us to better meet your needs, and to develop more impactful content. And we do thank you for helping us make a difference. Here's some links, and I'll share these again on Thursday to get to our website, to get to our GitHub channel, to get to our Slack channel, and also to email us codingforbnb@gmail.com. And that codingforbnb@gmail.com is also at the bottom of the page. And just to let you know, we've got some future workshops coming up, and I'll talk about these in more detail on Thursday. And I want to give credit where credit's due. So NSF, we have a collaborative grant at RIT, Wabash, Penn State, and James Madison University with a couple of numbers there. So we thankful to NSF, thankful to our organizations. I should have cleaned up this slide. We did a workshop at Rutgers 2 weeks ago, and I should have taken the Rutgers letter out, but the other four are our institutions. And the Molecular Software Institute, I always put them on because they taught me everything I know about Python. And with that, I'm going to mention a couple of details. I'll stop sharing my screen. One is, if you go to the bottom of your screen, you should see a More button. And I want you to click on that More button and find the Q&A. That will make Q&A appear on your baseline of your Zoom window. And any questions you have as we're going along, we would like you to ask them using the Q&A tab. Chat is also open, and we can use that as we need to, but it would be best for us if you could post questions in Q&A. If you have a question, somebody else probably has the same question. All right? And so appreciate that. We'll do our best to answer those. Oh, and I'm going to go over the poll. So I'm ending the poll, and I'm sharing the results. So the most popular book, about half of the folks like Leninger, another quarter like Stryer, Vote and Vote, and a couple votes for Tansy and for Garrett and Grisham. Your favorite Python textbook? We actually had two people select textbooks. And I think one of them was probably Wally picking Learning Python. I don't know if that, no, not Wally. Okay, never opened one in my life. And I see how you're feeling about today. Most people are feeling excited to learn. And we've got some other perspectives, a little nervous, and that's okay. And hopefully this will be a good opportunity for everybody to learn today. And I'm going to turn things over now to Mike.
Thank you so much. As Paul mentioned, I'll be talking a little bit about the pedagogical basis for coding. Oops, I assume I'm sharing, everybody can see correctly. Looks like I'm good to go. Okay, so why coding? Kind of why are we all here? Before I jump into too much details about the basis, the kind of way of thinking about teaching coding that we're going to ground a lot of our work in, I did want to overview a bit of the data that you all provided us in the workshop signup, just to kind of get a sense for who else is participating here. Most interestingly, perhaps to me, is we kind of have a nice spread of representation from different types of institutions. We have people from two-year institutions, high school, all the way up to R1, everything and anything in between. So we kind of have a nice representation, people interested in learning to code all over the place. Additionally, as far as our experience, we're all in a pretty similar boat. So self-assessing, most of us consider themselves just kind of beginning our journey into coding. So if you're nervous about, not really knowing at all what's going on, you're kind of among the majority here. A lot of us, a majority of us consider themselves beginners. Some say they have no experience at all. One brave soul said that they're proficient. I would like to pick that person's brain. The last thing I wanted to talk about was kind of what we identified as goals. So this was our ranking question. What did we rank the highest as far as our goal for the workshop? Luckily, we are all in the right place. We said, number one, we wanted to learn some basic coding. That is certainly the emphasis of this workshop, so that's good. And additionally, highly ranked item was improving our coding. Some basic goals. Hopefully we can attain those. One thing I did want to mention, draw our attention to, the three maybe lowest scoring, lowest ranked items. Just because they're the lowest doesn't mean that they're not a priority. But the thing that I want to talk about and maybe slowly slide these things up your own list are the last three items. So learning to teach code in particular and improving my teaching of coding. These are important goals that we want to emphasize all six of these, but in particular, I would like to make an argument for those two. Okay, so what are we going to take away from my spiel? Foremost, we're going to define something, a construct called computational literacy, and describe its three interconnected components. These are something called the material, cognitive, and social pillars. We want to articulate why computational skills are essential for our students, the next generation of biochemistry and molecular biology students. Identify three major barriers that maybe you yourself or generally faculty perceive in incorporating coding into their B&B courses. We want to ground this in something called the TPACK framework. So thinking about what sort of knowledge and experience and the intersection of that different knowledge and experience, how that plays into integrating coding. And then finally, describe and introduce two pedagogical strategies that in a meta sense, we're going to start introducing over the course of this workshop. We're not going to go into too many details about these pedagogical strategies, but it's something that we want to introduce to you, keep in the back of your mind as kind of what we're doing to facilitate these workshops and you to think about how you yourself could do that within your own courses. I guess last year now, we administered a survey to the wider B&B community, and we just wanted to get a sense, is there an interest in integrating coding into life sciences teaching? And overwhelmingly, there was. Ultimately, many of us were trained without coding, but many of our students are entering fields that are going to require some sort of coding experience. Most B&B faculty believe coding is important, but they don't yet teach it. So we found that 95% of faculty believe that coding is important, but only 62%, or rather 38% have never ran a coding activity within their classes. 62% have run none whatsoever. So there's this perception that it's important, but there's still kind of this sense that I don't really know how to do that yet. So to ground our workshop, our kind of thinking about what it means to train our students to code, we draw on a theoretical grounding of computational literacy. And you can think of this as a metaphor connecting to, like typical literacy, knowing how to read and write. In a similar sense, there's a computational literacy, knowing how to read and write, say, coding. So we draw on Andy DeSessa, who defines a new literacy as emerging when there's an adaptation of some tool or way of reasoning by a broad cultural group. So the tool that we're talking about is coding, and its uptake is kind of evident. Everything is talking about AI now. Everything is talking about automating systems. Everything is kind of pushing towards the need to code and use computational tools within our work. DeSessa delineates literacies to have three different pillars. The first pillar is the material pillar, and this is kind of what you think about when you hear coding. It's kind of the syntax. It's the ability to read and write and produce code. So material, this pillar is likely what students would be exposed to in a kind of introductory coding class. Another important pillar is the cognitive pillar. And this is kind of really good grounding for kind of our vision of why you should be coding in your classes. The cognitive pillar is all about the application of code to solve some problems. So you might be using code to run a simulation or model some sort of environment. So the cognitive pillar is grounding your material skills and abilities to actually solve some problem. And lastly, is the social pillar. Social pillar is all about communication. Obviously, this is important throughout the sciences, being able to say, comment your code so somebody could pick it up and read it themselves, or, create nice visuals with your code so that somebody can digest the cognitive outputs of the system that you're designing. So computational literacy has these three pillars. All three of these aspects are widely regarded as important 21st century skills and important for improving students' learning gains. So you might be asking yourself, why me? Why should I be thinking about integrating coding into my own classes? As I mentioned, number 4 and number 6 on this list, learning to code, improving my teaching to code, those were lower ranked on y'all's lists of importance, but it is kind of fundamental. If we think about the power of this metaphor, the computational literacy metaphor, it's all about grounding it in a context. One of the main pillars is the cognitive pillar, which places an emphasis on the application of coding and computation to solve problems. Sure, we could have our students go off and take an introductory coding class, and they can learn how to produce syntax, how to run for loops, how to think algorithmically in a computer science context. But what really matters is its application to solve our problems, its applications to analyze our data and make inferences contextually. So if they're just acontextually learning how to run a system, that doesn't necessarily mean they have the skills then to apply it to solve molecular biology questions. Additionally, the social pillar, this is kind of just a core scientific practice. If we think about the push towards open data, it's fundamental that students are prepared to produce code that can then be published alongside work so that somebody else could, say, reproduce their findings. And, along a similar vein, just methodological communication. And another important aspect is continuation with labs. If you have an REU student who, say, is doing some coding for you and they leave at the end of the summer, they shouldn't bring that code with them, You should be able to look at that code, give it to your next student who can then build off of it so they're not just starting from the ground up. Naturally, we know that there's some barriers that we face. So it's not just as simple. We have the sense perhaps that you have to be an expert to engage your students in coding. We're going to argue that that's not necessarily the case. So we talked about why now? As we've mentioned, computational literacy is a 21st century requirement. There's a growth in the types of fields within a B&B context, for instance, bioinformatics, computational biology, protein design, NGS analysis. All of these rely on computational skills. Furthermore, ASBMB, they've called and recognized computational skills are necessary within the B&B curricula. Computational literacy allows scientists to develop models and test hypotheses rapidly and inexpensively. There's lots of data. We need powerful tools to analyze it. Likewise, AlphaFold, AI-driven drug discovery, large-scale genomics, those are already present in the field. Our students need to know how to handle that. And finally, the Department of Labor, they're calling for AI literacy within the workforce. This is something that, we should get a head start on. According to the survey I alluded to previously, what do B&B faculty think is a natural introductory place for coding within their classes? This is things like plotting in Python, molecular visualization, Google Colab, protein sequence analysis. This kind of gives us a nice starting point, maybe a place to think about where you could integrate coding within your own class. And this kind of gave us a launching off point of where we were designing our own workshop activities. So for instance, today we'll be talking about plotting in Python. Okay, I alluded to this before. Why hasn't coding made it into most B&B classes? Well, there's several barriers that you may face yourself, but generally are perceived across B&B faculty. Foremost, coding is perceived as complex. Additionally, access to coding is not inclusive. And finally, we're reluctant to teach what we don't know, especially if we don't consider ourselves experts at something. So how do we address this? So the challenge. First one, coding feels hard. Students learn syntax and how to apply it. They need to learn syntax and how to apply it to specific tasks. So again, this grounding in the cognitive pillar of the social computation of computational literacy. Additionally, perception of difficulty and complexity, it remains high. If you ever tried to say, nobody or few people mentioned opening a coding textbook, and that's probably for good reason. If you tried to crack open a coding textbook, it's pretty dense. It's, called a language for a pretty good reason. It looks like a foreign language that it's got quite a high barrier to entry if you're trying to independently study it. The solution that we believe is the use of notebook-based learning. This is how our workshops are designed. You'll get an introduction to these notebooks in just a minute. Colab allows, the tool we'll be using, allows code to be provided in a ready-to-run format. Code is run in small sections, allowing for incremental progress. You're not just opening some blank terminal where you need to go from the ground up. These notebooks allow us to kind of start with something we can scaffold off of. Students learn coding while performing contextual B&B tasks. Again, this cognitive pillar that we discussed. And finally, notebooks are simple to run and modifiable for new problems. So again, we will have a set of notebooks that you will get your hands on. You could think about, while you're going through it, what are some things you would adjust if you were to, say, implement it in your own classes? These coding notebooks are nice because it's good scaffolding. It's easy just to save your own copy and edit it for whatever you need. The other barrier we mentioned was access and equity. So not everyone has the same resources. Depending on what institution you're at, computer access is going to vary greatly. Some students, can't even afford their own device. They just have to use whatever the library has access to. But, that could be a Mac or a Windows, and they might just be, say, a Linux user. So they might kind of be disenfranchised from, the tool that they have at their disposal. Foremost, poorly functioning facilities detract from learning to code. So if you need to, if you need to try to learn how to use Python, but your computer keeps crashing on yourself, you're going to quickly just, like the heck with this, I'm done with it. So the solution, we are using Google Colab. So again, this runs on any browser, so no installation is needed. You just need, Safari, anything that can open Google Colab, you can go ahead and run one of these notebooks. And finally, it's free. Google Colab, no downloading required, no subscription necessary to get the basic version. You can just open it up and get coding. And finally, and I think most importantly, faculty confidence. We have this perception that, I can't teach what I don't know, and, our threshold of what it means to know something is kind of, it's kind of at this plinth that we're not necessarily going to reach. So we have a lack of instructor confidence around programming. We have a lack of time, training, and professional development opportunities around coding. And, specifically, most B&B faculty have little experience training others to code. I might have learned independently how to code, but does that mean I know how to kind of tell somebody else how they should think about structuring their code? Not necessarily. The solution, turnkey materials and community. So we have pre-built code notebooks, Colab notebooks that are simple to run and modifiable. Again, you'll get your hands on some of them today. You'll see how easy it is to manipulate and kind of adjust to your own wishes. One methodology, again, that we will kind of, in a meta sense, illustrate today is something called live coding, where the instructor writes and runs code step by step for the students to see, or in this case, for you to see today. Our goal is to have a growing community of B&B faculty facing, the same challenges around implementing coding. So we see Code B&B, these workshops, the Slack, all of the different channels that we're creating as kind of the seedlings of a wider community that we hope to establish, where we're all kind of helping each other design notebooks, implement notebooks, think about assessing these notebooks, etc. But one thing I do want to take away is you don't need to be an expert. You just need to be one step ahead. You are, obviously intelligent to be at the stage that you're at. You can work your way through these notebooks. And if you can work your way through your notebook, you can have your students work through it. If they run into an issue, we have things like AI, your own experience, this community that you can use to kind of facilitate their own learning. So this leads us to kind of a theoretical grounding, a way in which we can think about what knowledge we need to code in our class. We're drawing on something called the TPACK framework, where we have these kind of this three-ring Venn diagram, where we have content knowledge. Content knowledge would be, your expertise in molecular biology. Pedagogical knowledge is all your knowledge about what it means to be an instructor. These two things intersect, where you have some knowledge of what it means to be a molecular biology instructor. You know how to write a good homework problem in a B&B context. The last circle we have is the technological knowledge. The technology, naturally, we're talking about today is coding. So we need to have some basic understanding of how to code. And then the hope is we can then start to think about, after we have this base understanding, how that can begin to intersect with our pedagogical knowledge, and then really importantly, how that can intersect with our B&B knowledge, our content knowledge. This is a little redundant with what Paul said, but this is kind of running through the things that we're going to be talking about over the next couple of days, and then grounded within our TPACK area. The one thing I want to draw our attention to is kind of this middle column, suggesting that we're kind of slowly building our way kind of towards the center of that Venn diagram. We're going to start with some basic technological knowledge. Then we're going to think about the technological knowledge in a B&B context, then start to kind of illustrate the pedagogical knowledge that relates to those two things. So the practice, and I really want to emphasize that we're not going to be teaching pedagogy in this workshop, but I think it's something that you can keep in the back of your mind and kind of in a meta sense, think about your own experience that could be relevant to coding in your classes. So in this workshop, we're talking context first. So concepts taught using B&B examples. We'll think about Michaelis-Menten kinetics, Bradford assays, protein sequences. We have incremental complexity. So, starting with some basic online resources, run code in small sections, scaffolding notebook, allowing modifications without starting from scratch. We'll be illustrating some live coding, again, where we are writing code kind of in front of all of you, and then maybe posing, stopping at some points, asking for your own contribution, your own instances to edit the code. And then finally, we'll leave you with something real. So the hope is at the end of Thursday, you'll have an opportunity to kind of think through one of the notebooks that we've worked through and think about how you could modify it, how you could adjust it for your own classrooms. So we're not going to be explicitly covering any of these pedagogical methodologies in this workshop, but in a meta sense, think about the way that we are introducing the material to you, and you could think about how you can modify it within your own classrooms. Okay, so what you'll leave with, a working Google Colab and GitHub setup. We already linked you the GitHub. A foundational Python skills grounded in B&B examples. Complete notebooks you can use in your own research or teaching. All of the notebooks that you're doing, you could, in theory, implement tomorrow into your own classes. And then finally, as a part of your participation here, you're entering a growing community of B&B coders. Cool. I will stop there.
Great. All right. Thanks very much, Mike. And what we're going to do now is move into GitHub basics. And Wally's going to take over here. Wally, go ahead. Wally, I think you're muted.
Oh, you unmuted me now, Paul, yes?
Yes.
Okay, thank you. Sorry, some of this might seem a little redundant. If you came to our April meeting, but I think it's always okay to see something again. I think there's a little bit of some new information in this presentation as well. GitHub can seem a little overwhelming at first, but it's a really powerful tool, and we're going to show you some workflows that I think make it really easy to work with and to share what you're working on with your students. A lot of what we're going to do today, some of this looking at GitHub, is not going to require any login or anything. When we want to do some of the things ourselves as an educator and store things and share them out, then we will require a login for GitHub. And that's a free thing that you can get. And hopefully many of you have already gone to github.com and gotten your own login. But let's go ahead and look at what we're going to tackle today. You'll know what GitHub is and how to navigate a repository so that you can find the stuff that we're going to work on. You'll be able to open any Colab notebook from GitHub or with or without an Open in Colab button. You'll be able to fork a repository, which is to copy that repository into your own directory. And if we have our time, which I hope we will, we'll create a new repository from scratch and save our first file into that. Finally, you should be able to describe how GitHub fosters open science. So let's start with some of the basics. This is really what GitHub is. It's kind of a combination of three things that we're familiar with. Very much like Google Drive or Dropbox, it's like a shared drive where we can store things, except for it's pretty much for code and files. It also lets us know, like a lab notebook, who changed things, when we changed things, and what we changed. So we can always go back to a previous version if and when mistakes were made. You can always go back to a specific version in time because it makes a log of that version history. And it's also like a publishing platform because we can share that information with other colleagues and students. The other reasons that we are using it is because GitHub is free for public repositories and it really integrates very well with Google Colab. I do hope that this ability to integrate with Colab and easily update materials changes how we can share information with our students. This is what GitHub will have. There's some definitions. A repository, this is just a folder that contains all of our files for a project, the code, any other notebooks and documentation. We have a README, that's kind of the gateway or front door. It's going to appear on the main page of any GitHub. And please always read that README first. It usually tells you how to use all of the files inside it. It can prevent a lot of confusion by reading it. A commit is a snapshot of your files at that specific moment in time. And there's a short message that's attached to that. If you don't change that, AI tries to fill in what that snapshot is doing, but it's always great to edit that yourself. A fork is your own personal copy of someone else's repository, and we'll show you how to fork a repository today. You can make any changes to that fork without affecting the original. And there are these things called branches. As far as we need to know today, there's one branch, it's called main, and we're going to just stick with that. But you can have other branches. This is what our repository is going to look like for today. So the repository name is up at the top left. This is called May26 underscore code BMB. Then near the top, you'll see a variety of folders for our data, images, and presentations. And then you'll see all of our notebooks, and they all end in IPY-NB. NB is notebook, and PY is Python. And at the bottom, we've got our README file. Now, what you can't see here is what's displayed underneath that. But let's go ahead and walk through opening this repository. And so we're going to do this now as a group, which is that we're going to open a browser, preferably Chrome because it integrates seamlessly with Colab, but we'll go to github.com and then we're going to type code BMB in the search bar and press enter. I'll click on that repository that says May26 code BMB, and we'll look at that README. And then that step 5, lastly, is we're going to click on file 001 intro to Google Colab. I'm going to go ahead and do this and walk through this. And I'm going to do it in an incognito window so I'm not logged in. So you can see that a student could do any of this also. Again, if you have questions during this, please do ask them in the Q&A. We're a small enough group that we can do that. So hopefully you see my incognito window now. And I'm going to go to github.com. And I said I was going to click in that search bar up at the top. And I'm just going to type code BMB. And I've got 2 results. And this is us right here. So I can just click on code BMB May 26th. And that should look a lot like the slide I just showed. But I'll scroll down and you can see that the README is in fact displayed. I can click on that README file and it will show me the same thing, but it's automatically displayed. And it tells us, oh, we wanted you to register, have a Google account and GitHub account, and what our schedule is for the day. And so that's some of the information that we've got here. I also wanted us to go ahead and click on this button for the intro to Google Colab. So I will do that. It's not a button. Click on this link. And we can see what this notebook looks like in GitHub we don't need an account to do any of this. A student can look at this. We can see all of the code uh, that everything in that notebook that was written, all without a login because it's a public repository. So, and that's what I want to emphasize here. Students, if you're working with students on this and they want to run your code, they do not need a login for GitHub. They don't need to know anything about GitHub other than the address of how to get there. I'm going to head back to my presentation briefly. Okay, so let's go ahead and open a notebook. There are two ways to open a notebook. I'll talk through the first one because it's the easiest, which is click the Open in Colab button. That was sometimes it's in the README file, sometimes it's directly in the notebook itself. And then what we will do is do File, Save a Copy in Drive, and that's going to save it to our Google Drive. So if you're already logged in on Chrome and have your access to your drive, it's very straightforward. I am going to go ahead and go back into my Google Chrome, but I'm going to close this window and go back here to github.com. I'm just navigating to where I was, but now I'm all logged in. So when I do this, we had clicked on Intro to Google Colab. And so the first way then to open that is simply to click this Open in Colab button. It may ask you some questions if you've never associated Google your Drive with GitHub. And so you just want to say, yes, you have permission to interact. And then it should open for you and look like this. That's our first way and the easiest way that any student can open that. So all they would need then is a Google account. They don't need a GitHub account. They just need a Google account, and they can open any file that we've got that's public. I'm going to jump back here and show you that there's another way. Sometimes there's no Open in Colab button. And so it's still very easy to open those. But what we're going to want to have is the complete URL of our repository that we want to access. And so that's something you can provide to students, or I can just copy that. So what I am going to do is I'm going to open a new browser window. I'm going to go straight to Colab and say File, Open a Notebook. I'll click on the GitHub tab, and I'm going to paste the full repository. So let's go ahead and do that. I am first, before I do that, let's see. I'm first going to go back here to my code BMB. And I'm just going to copy this address. All right. So I said I'll go to colab.research.google.com. I'll click return. That didn't not do what I thought. I clicked the wrong button. Colab.research.google.com. That's what that's supposed to look like. I somehow launched an AI tool. And now I'm going to just click on GitHub. You can see I can open things from Google Drive, I can open things from GitHub, or I can upload them from my computer. But I'll click on GitHub. And I need to put in this search tool, it says enter a GitHub URL. So I'm just going to paste what I just copied, github.com/codebmb, and I'm going to click search. And now it's going to show me all the notebooks right there in that public repository. And I'll just click on the first one, Intro to Google Colab. So that's our second way of using GitHub and accessing it to open any notebook. So just to cement this, you can always go to colab.research.google.com and do File, Open Notebook, and you can open any public notebook. anywhere in GitHub. All you need is the address. You can also open anything in your Google Drive that is a notebook. But all you have to do is paste that repository URL from the web browser, and you'll get a list of all the notebooks inside. Okay. So what do you need a GitHub account for? You do need one, yes, and hopefully you have one today. You don't need one to, again, read things, open things, um, or even download files. But we are going to need a GitHub account to fork or copy a repository, save your work back to GitHub, create your own repository, and share things publicly, for example, with your students or collaborators. And contribute back to the Code B&B community, because when you start designing really cool things that other people want to use, you'll want to share that out. So it's very fast if you haven't made it already. It does take only about 2 minutes to make a GitHub account. And so please make one if you haven't already. So what the first thing that we'll show you is how to fork a repository, which is, again, copying it to your own directory, your own personal GitHub account. The instructions are here. It's just go to github.com to this repository /codebnb/May26. And then we're going to click the fork button. It's going to be at the top right corner of the page. We're going to leave all the settings as default and click create fork. And whoops, I accidentally clicked ahead. And GitHub will build us our new repository at github.com, whatever your GitHub username is, /May26CodeBNB. All right. I'm going to come back to this slide because I'll highlight this after we do this. So let's go ahead and practice this. I'm going to close these intro to Colab windows, and I'm just sitting back in GitHub. If I come over here to this fork button, I can click it. I'd love to see this number climb. So if you've got a GitHub account, click that fork button. And you see that it's going to, it says, oh, /Wally Novak /May26CodeBNB is available, because I don't have a directory named that, a repository named that. So that's fine. I am just going to copy the main branch. I don't need to change anything else here. And I'll click create fork. So this is copying everything from that repository into my own personal directory. So you can see up at the top left, Wally Novak /May26CodeBNB, and I have access to everything that we had access to before. Now, I do want to go and show you one caveat here. If I click on Intro to Google Colab, and if I click on this link right here, and if I look down, I don't know if you can see it in my bar, but if I look down at the lower left, it says that this is going to open Code BMB's version. So if this Colab open in Colab button is still actually going to open the version from Code BMB instead of my own version. So I wouldn't want to open it this way. And that's what my nota bene on my PowerPoint says here. Don't use the open in Colab button the first time you open your forked notebook. It will still point to the repository at CodeBNB. Instead, use that method 2, where we go to colab.research.google.com, put in the URL of your new forked repository, which you can just copy, and then open it that way. When we save it back, it'll actually update the Google Colab link, and it'll be yours. Okay, so that got us to forking our repository. Let's try creating a new repository. So we're going to go to our own github.com/your username. So that's whatever your GitHub is. And we're going to find the plus icon in the top right-hand corner. And it's a drop-down menu, new repository. And we can call this whatever we want. You can call it test if you want. It doesn't really matter, but you can give it something descriptive. You can call it, May 26 test, May 2026 test. Make sure your visibility is public, just as a good practice. Even if you're just messing around, that's totally fine. And make sure we click to add the README file because it's really good practice to always add that README. And then we're going to click Create Repository. So let's practice that. So I'm just going to go click on my username to go to github.com/your username. And here's that plus over here in that top right corner. So if I click this drop down menu, and I'm sorry, I have to move all of my people from Zoom because I can't see behind it. Create new repository. And so this is where I can name it. I can name it, test May26. This is a demo. I'm going to make it public. I'm going to click the add README file. And I don't need to say anything else right now. There are different licenses that you can select in terms of how you want your creations licensed, but we don't need to do that to create this. And we're just going to click Create Repository. And look, it opened up with our README file, and that's a new repository, and it's just at Wally Novak /test May26. So everyone can access this. It's public. I'm going to take just a breath here and see how people are doing. While we do that, I'm going to talk about part two, which is actually adding a new notebook and saving it to our repository. All right. This is kind of the last new big thing. It's like if I create something, can I save it back to my GitHub account so that students can use it, so that I can edit it, so that I have that version control? So I'm just going to start by going back to colab.research.google.com. I'm going to click a new notebook, right? We're going to click new notebook. I do suggest naming it something other than untitled, whatever. It's going to have some number after it. And then we're going to do save a copy in GitHub. It might ask you to authorize, again, this communication, and we'll find our repository and save it. And we're going to check that include a link to Colab button. So we're going to save our first. It's going to be a notebook that doesn't have anything in it, but it's going to show us how to do this. Okay. So I want to make sure I've got my instructions up to follow that. Oops. So I'm going to open a new window. I'm going to go to colab.research.google.com. And down at the right here is this new notebook. So I'll click that. All right, I've got an empty notebook. I actually don't have to put anything in here, but I am going to click up here. I'm going to leave the .ipynb, and I'm just going to say this test_notebook. Right now, it's just saved in the Colab environment, but I want to do File, Save a Copy in GitHub. I'm going to select my new repository, if I can find it. It's called, here it is, Wally Novak /test May26. And it's in my main branch. And I'm going to say, this is my first notebook in GitHub. And I've got the include a link to Colab button. And I'll click OK. So it's now bounced me back. It's opened up a new window. And you can see I've got this open in Colab button. So I can open this back right in Colab. And if I go back and refresh my main screen here, you can see that I've added test_notebook. So I've made my first, I've added my first file to GitHub. Okay. Want to get us as close to on time as we can. And so let me go back to my PowerPoint. Nope. Here we go. And just quickly mention, there are three ways that you can save things. We just did option two, saving it to GitHub, whether that's through your forked repository. Um, you can do option three, which is to download it. You can save that file locally to your own computer. It's great as a backup. It does not make sense as part of a workflow to work on these things. Um, the one that's probably still best for today would just be to go to your notebook and say File, save a copy in Google Drive. You're welcome to do the second one, save to GitHub, as long as it's not going to be a big issue in terms of slowing you down with looking at things. Saving a copy in Google Drive, it will appear in your Colab Notebooks folder in your Google Drive. And it's just very easy to access. You can always then save a copy later to GitHub. So there's no problems doing that. This is a fast and easy one for today. I'm going to just skip over this in order to kind of get us back on track. But hopefully we've learned to navigate to a GitHub repository, open any repository, copy one, create a new repository, and save our work to Google Drive or to a backup. With that, I'm going to turn it over to my colleague Chris for actually looking at Notebook 1.
All right, thanks, Wally. Oh, go
Chris,
ahead,
could I
Paul.
say something for just a second? Now, keep in mind that the four of us who are leading this workshop have been working with Python and notebooks for somewhere between 5 and 25 years. Okay, so we've seen a lot of stuff. If you're brand new to this and we do stuff and we just flash by it too quickly, pop something in the Q&A window and say, how did you do that? Because one of us is presenting, that means the other three are watching the Q&A window. We're happy to help. Chris.
All right, thanks, Paul. It's a good reminder of the same thing we would do with our students. We want them to ask questions and always engage. So, all right, I'm going to share. So this is the GitHub for today's workshop, and we'll be doing the Intro to Colab uh, notebook right here. So if you click on that and then open this in Colab, it'll bring you to what I'll be working through. And you can either watch what I'm doing or you can follow along, whatever works best for you. I've got my version already set up, and um, this is the Colab that's going to walk you through how to use Colab, how to interact with it, how to use it as a tool in your classroom. And thinking about how I use it, a lot of my students use Colab as an interface for doing some pretty cool things like molecular dynamics or protein modeling. We're not doing a lot of coding in my class, but that's just because the students I have are mostly pre-meds, and their focus is really trying to get the information integrated as soon as they can. So for me, I'm using Colab as a way to convey types of software that would be difficult to do otherwise, but they do interact with the code on a limited basis as well. So hopefully everyone's got their Colab up, and I'm going to hide the table of contents just to make my screen a little bit bigger and make it easier for you all to see the full expanse here. We're going to start working our way down through it. And the first thing you should do is make a copy for yourself if you haven't already. And you can do that by going up to File, Save a Copy in Drive, and then it will automatically make a new tab. That will be Copy of Intro to Colab. Then if you want to change the name of that, you can click on the name up here and change it to whatever you want. I made it a separate copy already so that I can edit this without affecting the GitHub. But you can go up here and just like a Google Doc, you can change this to a new version or whatever works best for you. Then, as Wally showed you very nicely, you can save this and save your work. Now, if you've saved this in Google Drive, it will auto-save every few moments, just like you have with a Google Doc or any other Google product. But you can also go in here and save it in GitHub. You can save it as a notebook and download it. There are a variety of ways that you can do this. We're encouraging you to use GitHub overall. But as you're going through here, if you don't save it to GitHub every few minutes, that's fine. Google Drive will automatically save this until you then export that version over to GitHub. Now, within this particular Colab, there are two types of blocks. And if you've been clicking at all, you may have already run into this, in that you can have text blocks, which is what we've been seeing so far, as well as code blocks. And the text blocks, if you double click on section 3, it will reveal the editing window. So on the left side is the markdown language that produces the text as you see it on the right side. And you could do a variety of edits to it. You could just type text in here and then use the buttons across the top to modify it, just like you would in Word or in Docs. Or if you know how to do the shortcuts, you can type them in as you're going and produce that text as you want. So if we went in here, I could double click on this text box and say, this is a header. This is bold text. And as I'm writing it, it will appear on the right side. And so if I want to make this bold, as the name suggests, I can highlight it and add the asterisks, or I can just add the asterisks as I go along, and it will format the text for me as well. So there are a lot of ways that you can do the edits as you're going along here and create text. And I'm using these text boxes to show my students, these are what you need to do. This is the background information. These are the places that you would use it, like a guide or a handout you would use in class. Once I click close, I've got just the text. And if you want to reduce this down, since we have a header here, this is little down arrow, you can click this and it will hide things as you're going along. So if you ever come into a Colab and it doesn't look like it's showing everything, you can push this triangle and it'll reveal things along the way for you. Now there are also code cells, and that is what I have here. And you can type code in here directly. So we'll do the standard first code that a lot of people like to do, which is where you type print and then parentheses and quote, and you type hello world. And now we've got our code written. Now to run the code, we would want to first connect and then push play, and then we'll run over here. We'll come back to this in a moment, but for now, don't connect or run it quite yet. We'll do that when we actually do connect into it. But we've got our code written, and this is the difference between the code block and the text block. Here is the look of the text that is in each of those blocks. Now, if you want to add a new block, you hover your arrow either to the top or the bottom of the block that you're currently in. And you can either push plus code or plus text, and it will add new blocks for you. All right. Now, along the way, you also may want to change the look of your Colab or have certain tools enabled. And you can use this by going to Tools and then Settings. And there's a number of things that you can change. The site is what you do, light mode or dark mode, and how you've got it oriented. The editor is what it looks like in the code blocks themselves, along with if you have any helps. I like to leave line numbers on, especially for my students. I can say go to line 3 or go to line 4 and try to help them find things. And the indentation guides are something that doesn't make sense if you've never done coding before, but if you've done a little bit, there are times when you need to put certain code underneath other code. And those indentation guides show you where you want to line up your lower level types of code. There are other things you can add on there as well. Like here, you can add crabs or kitties or corgis and have them walking across the top of your screen. You can integrate it with GitHub in different ways. I have a Colab Pro account, which you can get for free if you're an educator. You just have to sign up. And you can have AI assistants. Right now, I've got those turned off for this particular notebook, but later on, we will get into that. And again, I recommend having line numbers and indentation guides on. I find it's helpful as I'm writing my code to not only be able to keep track of things myself, but also when I'm talking to students about their code. Now, we haven't run any code yet, and we haven't connected to a runtime. At least I haven't yet, and that's because we haven't talked about it. But Colab lets you choose Python or R or Julia as your coding language. and you're running the Colab, you're running the code on someone else's computer. So it doesn't run on your laptop or your phone or your tablet when it's running. It's running on Google's computers at some data center. Now there are different types of run types. I click the down arrow here, I can click change run type, and it gives me a number of options. For most of what we're doing in this particular workshop, the CPU is fine. It's you don't need advanced GPUs. But if you were going to do, say, run AlphaFold or do molecular dynamics, you may then want to investigate these GPUs. And this is where the Pro account is helpful because that gives you access to these GPUs that you don't normally have access to. Uh, at least you don't have a lot of access to if you don't have the Pro account. So if you're going to be teaching coding and doing data fitting, you'll be okay with just using a CPU. If you want to use it for other pursuits like modeling or really, really big data sets, then you may want to investigate getting the free account of the Pro account. All right. Now I'm going to connect to my runtime by pushing the connect button. This is one way to connect to the runtime. The other way to do it would be pushing the play button above, and that allows you, it'll automatically connect, and then it will run your code. So now I've got the green check mark, I'm connected, and now I can run code. So we can come back up here earlier where we did our print hello world, and I push the play button here on the left side, and that runs the cell, and it prints hello world. There are other codes that we can run here below, such as this one, which will give the date and time, or it looks like that's probably what London time, I believe. So it's running European time here, but that gives you a message as well. And this is an indicator that the code ran. Now there is a green check mark next to the code block. That means it ran. If it fails, then you'll get a red X. And if it does run or if it fails, it will also give you a number, and that tells you the number in which the cells were run. So we ran a cell above where I did print hello world, that was 1. I just ran this, that was 2. If I push it again, it will increase to 3 because I just ran that 1/3. And so this can help you keep track of when certain things are running. Now you may have noticed in this code block that I've got something that says import here. It says import date time. That's because we needed specific library of code. You can think of it like a software package to be able to do what it says here, to go get the date and to run it and to produce the result. And there are lots of libraries and packages that are built into Colab already. So all you would need to do is do this import command. But there are others that are not. And ones that I know that I use a lot are like AlphaFold or Colab fold. If we're doing something like that, then I have to install them using this pip install and bring it in this way. So in this code block, we have the pip install command and then the library that I want to install. And then I'm going to have it suppress all the messages that it produces, and that's what the quiet means. So if I run this code block, it's going to install, and then it's going to do the command. I'm going to import the emoji, and then it's going to print out Python is awesome, and it has a snake in there in emoji format. So I installed the library. In this case, it was the emoji library. I then told Colab to import it so that it knew that it was necessary for use, and then printed it, and we did the command here. Now, there's lots of ways you could do this, and if you want to try writing your own code, you can click on this link for possible emoji codes, and it will take you to a website that allow you just to look around. So if you're looking for like a beach or something like that, you can then incorporate emojis into your code. And so I've got an example here where I say I write code on a desktop computer, but I've got desktop computer in emoji format, and it prints it out down below. All right, so some of you may be wanting to play with that. I'm going to take a moment and take a drink of water, let you all catch up, think about questions, and then we'll move on to the next section. All right. Now, in the code blocks that I've run so far, you may have noticed that there's two different types of text. There's on line 1 here, I have this text that comes after this hashtag or pound sign, and then I have the code written on line 2. The line of text that's written on line 1 are the comments, and you can use these comments to not only keep track of what you're thinking about or trying to do, but also you can use it to guide others. Think of it like your lab notebook, where you're trying to provide information so that others can look back on it, or you can look back on it and keep track of things. So a comment will always come after the hashtag or the pound sign. And it can either be before the code, as here we have this is the comment, Python ignores this line, and then below it is x equals 5. Or you can put it directly in line with your code. You can say, you can also add comments at the end of the line. If you have a multi-line comment that you want to make, you would do that after 3 quotes. And that will allow you to put in multiple lines, text, paragraphs, whatever you need to do in there. And so here we have some code that you can then comment and add it onto. So let's work through this one together. So sometimes it's not clear what you want to add the comment for, and so you may want to run the code, see what it does, and then you can go back and try to figure out based on what you see what it might have done. So I've got temperature Celsius and equals a bunch of numbers. Well, it looks like those numbers are the starting points here on the left side of this particular output. So this could be starting temperatures. And then in line 8 on my screen, it looks like there's doing some math. So I might write doing some math. Or if I knew what it was, I might say equation to convert Celsius to Fahrenheit. And then I can go in and say, this is print the results. And so this would be a good start. As I learn more about the code, get more comfortable, I might go back and refine this and say, oh, these aren't the starting temperatures. This is my list of temperatures once I learned what a list was. And so this is a good teaching tool as well. Sometimes I'll give students naked code like this and say, comment it, figure out what it's doing, and use that to help guide them through working through the code, trying to understand the structure of what they're doing. All right. So we've worked through the basics of setting the text blocks and the code blocks. We've worked through a little bit of code. We've talked about commenting. Now we can talk about how we get things into Colab and then back out as well. So there are a couple different ways that you can upload your data. There is the direct upload. On the left side of my screen, there are 7 icons here. There's a one that looks like a file folder. If I click on that, I can drag my files into this space, and then I can access them directly, very similarly to what you might do on your own laptop or something like that. Now, I do want to point out that anything you upload to Colab is accessible to Google, and you may want to look at the privacy statement of Google before you upload too much. But I do know that it is not FERPA or HIPAA compliant. So don't put anything up there that has patient information or has student records or anything like that. It will not be compliant. So when you're uploading your data, you can directly upload it. We can connect to Google Drive, which we'll do in a moment, or we can also import the file from a GitHub repo. And this is very similar to what Wally has shown you, but we'll build on it a little bit more. So if I wanted to connect it to Google Drive, I would use code very similar to this. And this is general code for importing for Google Drive. So if you're doing this in the future, want to write your own way to connect it to Google Drive, you can come back to this Colab and copy this code into there, and that'll be a good start for getting you into Google Drive. So if I click on this, it's going to say, do I want to allow this notebook to access Google Drive? I say yes, and then I'll do a series of authentication steps. And it will run for another moment, and I can tell it's running because I've got this little line that's circling the stop button. And it will then say that it's mounted and we're ready to go. Now, to get into those folders, you want to know your file path. And content drive, my drive, is pretty standard for Google Drive. And then you put the path to your folder. So down here in this code block, I want to look at my JMU folder that I have on my drive. So I'm going to type in JMU. That'll be the general file path that I use. And then this code will look at the first set of files that I've got in my JMU folder. I doubt anyone in this Zoom has a JMU folder, so you would want to put your own folder name in that spot. And you can then have it connect, and then it'll list all the files that are in that particular folder. So I've got all the work stuff that I've got there. And then the last way we can do this is import from Google Drive. There are a couple different ways to do it in terms of you can clone the repository and open the notebook like Wally showed you. But if you want raw file access, you can go back to a repository. And in this case, I'm going to look at the data folder. I can click on a file and I can take the link up here and copy that into the Colab, as I've already done here. The only difference between that link and the link I copied in is this word raw. The one in the internet bar right now has blob, B-L-O-B. I changed it to raw after I pasted it in. And that is what you need to do to get this to run. So I'm going to run this, and it's going to import the file from GitHub, and then it's going to display the top part. And these steps that are running on lines 4 through 12, we'll talk about in a later session. But I've now imported that file, and now I can use it and do other types of manipulations. The last section I'm going to show you is how to share the notebook. If you've got it on GitHub, you can send people that to your GitHub repository and have them do it. The other option is there's a share button up here at the top right, very similar to what you see with Google Docs. If you click on the share button, it will give you the menu that you are probably familiar with if you've shared a Google Doc, where you can provide access. And then you can change whether they're a viewer, editor, or commenter. So very much the standard Google Drive structure for how you can give access to things. And you can share that link with someone. So when I'm thinking about giving access to my students, I'm sometimes giving them a GitHub link. And in other cases, if I don't have that particular notebook up on GitHub yet, I will just send them the Google Drive link, and it will work out just fine. Now, if they're a viewer, they can make a copy of the document, and then they can go ahead and edit it on their own. But most of my students never make their own copy. They just run it as I send it to them. It won't save anything, but it will run the code for them. And yeah, let's see, how am I doing on time? I think I'm right at the limit. All right, so I'm a little over. I'm going to stop here, and we'll take a little bit of a break. I don't know, Paul, if there's anything else you all want to introduce before we go on break.
No, I think now's a good time for a break. We'll come back at 2:25 and we'll keep going. So we've got 8 or 9 minutes to go. And during this time, if you have questions for us, I'm going to, what am I going to do? I'm going to change controls here on the participants. I know I've got an option to do that. And you can unmute yourself if you want to ask a question. I'll put the mute thing back on when we're done. But if you want to come on and ask a question, you can do that. And I'm sure at least one of us will still be in the room. I've got to run down the hall to see a couple of research students, but there'll be people in the room and we can answer your questions. Or just get up and stretch. We've been going at you for about an hour and 10 minutes, hour and 20 minutes here. So
I've got a quick question. This is Josh Beckham.
sure, Josh.
Chris, if you give them the instructor's notebook and the students are running it, if they are creating data or accessing data into the notebook, will it, I guess they can access it from your GitHub or your repository, but if they're creating data and like writing it to a file, would it save into a communal folder or would it save in to your existing directory, I guess?
Yeah, that's a great question. So in terms of the data they're creating, say they're doing a simulation or something like that, the files that are produced are saved in that local area on the Google Colab underneath the file folder, usually, unless they've connected it to their Google Drive, and then the files may save back there. So part of it is how you structure the activity, but I never see what the students are doing in terms of data unless they intentionally share it back to me.
Okay. Okay, that sounds good. Just being intentional about where they're saving it.
Right.
Think about that beforehand. Okay, thanks.
Yeah, and I often will build in guides to help them and say, I'm going to create an outputs folder in your Google Drive, and you're going to import the data from your Google Drive, and then it's going to go into this outputs folder. And that way we're not commingling data and analysis or something like that.
Yeah, which sometimes you want them to be able to see each other's data, but it can get really messy too with raw data.
Yeah.
Okay, thanks.
Mm-hmm.
And our intention is to make this recording available to folks. I'm not sure how quickly we can turn it around, but we'll try to get up there as quickly as we can. And the nice thing about that is I'm sure that we've gone too fast in many ways, and you can slow us down just by clicking pause and getting us to stop. All right, so I'm going to share my screen, and we're going to now look at some basics of Python syntax. And once again, while this is going on, first of all, I'm going to change some rules here. I'm going to turn off the unmute. You can still chat, but this way there'll be no temptation to interrupt. All right, so here we are, and don't do that. Going back into our folder. And I'm going to go to Notebook 2, which is Python. And so you should see this window. All right, and we just click on the Open in Colab button here. And that takes us to this page. And I turned on that corgi thing. Chris mentioned that. I thought I'd try that. So I've got corgis running across the top of my screen here. And the first thing to do then is to go in here and save a copy to Drive. And I like to put names on it like Paul's 19 May 2026 copy of that notebook. Okay? And just to know where it is. So we're going to look at some basics of Python syntax here, just so we can follow it a bit and learn a little bit about the steps to take. Now, once again, anytime we use a cell, you can run the contents of a code cell by clicking on the Run button. You can also run the contents of a code cell by clicking Shift-Enter, okay? For this notebook, we don't need to set up any special environment or libraries. We're just using basic Python functions. In the future notebooks, we'll be looking at some different libraries we'll be loading and using. And the first thing we're going to do is just what Chris showed before about importing Google Drive and getting that ready to go. And notice when I click it, there's this dotted line going around there. That dotted line, I think, is something like telling the cloud it's time to wake up, okay? And then when the solid line starts going around, that means it's actually taking action. So at this point, I'm not sure you're seeing the screen, but it's asking for permission to connect to my notebooks. Or I'm sorry, to my Google Drive. And so it'll do that. And this was box 1 here, and it took 19 seconds to do that. I'll wait a couple seconds for you to catch up on that. While I'm waiting, I'm going to go up to Tools. I'm going to turn off the corgis for right now. All right, so in this notebook, we're going to learn to navigate and execute code in a Google Colab notebook. We'll look a little bit at basics of syntax, data types, variables, operations, and look at what Python is. And once again, we're very much focused on how can I use Python for my teaching and my research. Okay, so our goal is not to teach an extensive broad base of Python theory and background. Our goal is to teach enough of the tools that you can use it for yourself and that you can find a notebook that somebody else has written, bring it in, and as long as it's licensed under something like MIT license, open source license, you can use that, okay, with your students, and you can modify it. So we'll be looking at basics in Python and Colab. We've actually done quite a bit of that. We'll look at variables, data types, loops, and logic statements. And I probably won't execute all of the cells here, but we'll do some of them. I'm also going to turn off actually, I'm not going to turn off. So if we go into this cell here, we're looking at assigning variables. Now the number here, 1, that means it's just line 1 of the code. And there's a sum there, 3 plus 9. If I hit a run button, then it sums it, okay? It adds it up. So we get 12, okay? We could change that to a multiplication button, just an asterisk, get 27. Okay, so we could use Python as a calculator, but usually when we use coding, we want to be assigning things to variables so we can use them later, okay? So the standard format is we create some variable name, and then we assign a value to it. And that value could be a whole number, we call those integers, or a floating point number, and we call those floats. Those are decimal numbers then. We can also use strings, and we'll do that with quotes, and you've already done that actually when you did the print hello world function. You were using the string hello world, it was inside quotes. Now, what we're going to do here first is I want to show you some of the things that happen when you're in Colab, and it doesn't always work the same on everybody's screen, but so we're looking at a problem here with a Michaelis-Menten calculation to determine enzyme velocity. So the problem is, what is the reaction velocity if the Michaelis constant for this enzyme is 15.0 micromolar, and the maximum velocity is 100.0 nanomoles per second, and the substrate concentration is 8.0 micromolar. So I have a comment here, notice the pound sign, calculations using the Michaelis-Menten equation. So I come down here and I say Km equals, put a space, and notice a whole bunch of stuff shows up here, all right? So if I hit tab, I can look at this and I can see that it assigned the Km of 15.0, which matches what we have in the text. Vmax of 100.0 matches what we have in the text, and substrate concentration equals 8.0, so it matches all that stuff, but it also produces the Michaelis-Menten equation. Now, I've done this notebook 100 times, So Colab has seen this many, many times, and it knows how to do this automatically. All right. So if I run this, well, first of all, I want to take a second. Can I get some thumbs up from people to let me know, did this work for you or not? Did you see the code come up like that? Okay, seeing some thumbs up from folks. I don't need a whole lot of people applying, but if 2 or 3 people reply, that's really great. One of the things that's real interesting being on this team also is that Chris and Wally and I are all from the biochemistry, biophysics, molecular biology area. Mike is actually a mathematician. And so it was fun listening to him present his initial talk on pedagogy. And he was talking about the terms. But the fact is that those terms are relatively foreign to him. He did it very nicely, but it was still fun to watch. All right, so it's done all this stuff for us, and I just hit the run button, and it calculates and gives us an answer. Now notice the answer here is with a certain number of digits and so forth. We'll get to this later, but also notice under this cell, there's a click to see the answer. So this explains what you need to do. This shows the code. And now, so we have this statement that says print velocity. And so this gives us the answer. And when I have this statement, print is a function, and whatever's inside the parentheses is what it prints. Okay, so it actually is going to print the value of the variable velocity if I run this cell. Okay, and so these variables are what we call immutable. That means once you assign a value to them, it doesn't change. So if I go to the next cell and I say print velocity, and then I say velocity equals velocity times 60, and say print velocity, what we see is that it actually, we assigned a new value to that same variable. This is generally not a good practice, okay? You generally, if you're going to have, if you're going to change a variable like that, you probably want to change the name. So I'm going to do that actually in the next cell. The first thing I'll do in this cell is I'm going to change the velocity back to where it was. So I'm going to take that value, divide by 60 to counteract what I had done here. Then I'm going to declare a new variable, v underscore nanomoles underscore per underscore minute. And I think I want to mention something here. Why do I have an underscore there? You don't want to have spaces in variable names. Okay, you don't have spaces in file names. It's just generally not a good practice. Okay, so I'm declaring a second variable here. And when I do that, I'll print the values. And you can see that I have the value for velocity is back to the number we saw before, and the value for this new variable is printed beneath it. All right, I'm going to take 2 minutes here, and I just want you to look at this exercise. It says in the code box below, create a variable called km2, set the value to be 30, and then print it. So I just want to give you 2 minutes to do that. Once you've done that, if you could give me a thumbs up. And I'm going to remove the pins on the speakers here so that I can see everybody and I can see the thumbs going up. Okay, I see 2 or 3 thumbs going up. That's great. Is there an icon for I'm in trouble? I don't know if there is. But anyway, if you have trouble at any point along the way here, please use the Q&A and post a question there. Okay, and if you click, you can click to see the answer below here. So we just define the variable km2 equals 30. And notice I put in a pound sign micromolar, so you can have a comment later in a code line, and it doesn't affect the code. And then I just print the variable as it indicates here. Now, when we work in Python, there are a number of data types that we use, and we can find out the data type by using. If I put type and then I put the name of a variable inside the parentheses and I hit the run button, please do that. You'll see that the type for this is full. Now, you can change the data type for a variable, and we call this type casting or casting. And so what I'm going to do is I'm going to declare a new variable called velocity string, and I'm going to make it a string str for the original variable velocity. Now notice when I mouse over this variable, it actually gives me the value of that variable. And so then I'm going to find out the type of the variable velocity string. So when I run that, I see that it is str, or a string. Okay, I've got another exercise here. What I want you to do is convert velocity to an integer using the int function and print the results. And I'll give you a minute to do that. Give me a thumbs up when that's working for you. Okay. Seeing a few thumbs up there. All right. All right. And so the actual code for this is, once again, I can just go in here and start typing, and I can say, we'll call it velocity underscore int, and then it types the rest of the code in there. I'm not sure if it remembers it because I'm logged in as myself and I've been doing this exercise before. When I write this, it tells me that the class for that for velocity int is that. In fact, I don't think I needed the print function there. I think if I just have type velocity int, it just gives me int. All right. So those are for simple variables, just single values. So a single number or a single string. Now, one thing that we do a lot in Python is we use different data types. One of those data types is called a list. Python is very, very particular about the way you use different forms of brackets. So square brackets are used. One of the functions in square brackets is to enclose a list. Parentheses are used quite often with functions. So for example, with this type velocity int, we have type as a function. We have the parentheses on either side of the variable. Okay, that's used quite a lot with functions. Curly brackets are used in something called fprint statements, and they're also used in dictionaries. And we'll talk more about fprint statements later. All right, so if we look at in this box, I have a comment. This is a list. And so I've got this list, substrate underscore CONCS, okay? So this is a list of substrate concentrations. It's shown here. And then I've got a comment to say that these are micromolar concentrations. Now it's possible to determine the length of a list. So if I want to determine the length of that list, I'll call it S underscore length. And there's a function called len. And so this is a function that's available in standard Python without any libraries added. So I type in len, and I put in substrate concentrations. And so that variable is in that variable. And now we want to print the length of that list. And so we say print, and then in quotes, this list contains, close the quote, comma, the variable name, S underscore length, comma, and then in quotes, substrate concentrations. Okay? And I want to use good English, so I'm going to put a period in there. Come on. There. I put a period there. Notice that this is an error. This happens all the time, okay? And I got sloppy. I put a period there when I meant to put it here. So if I take the period out, it tells me that there are 13 substrate concentrations in that list. Now, I'm going to talk just a little bit about fprinting, okay? And the form of the print statement we used here is shown here. So we've got print, we've got text in quotes. It could be either single or double quotes. They just have to match. A comma, then a variable, then a comma, and then single or double quotes again around text, okay? There's another form we use called fprinting. With fprinting, we say print, open a parentheses, put an F, and then put a single quote or a double quote. Then you have some text, And any variable you want to include, you include inside curly brackets, then additional text, and then another variable in curly brackets, and then close the quote, same quote type. So here's a print statement. Print F, and this list contains, and then S length, which is one of the variables we had. And if I print that, it gives me exactly the same statement as I saw before. Now, the reason I like F print statements is that I don't have to figure out where the spaces are with the comma here for S around the variables. I just have brackets around the variables, and the spaces are exactly what I see on the screen. Okay? All right. So I'm just looking at the time. I'm not going to do this cell. The next cell, it does have an important function for us. There's a function called append, and append lets us add a value to the end of a list. So I've got this list called substrate concentrations, which we looked at above, and I just want to add the value 1000 to the end of the list. And so if I use substrate underscore concs dot append, and then in parentheses put the value 1000 and hit the run button, you'll notice that my list now contains, in addition to the other values, it contains a value of 1000 on the end. All right? And there's an exercise here that we're going to skip, but I encourage you to come back and do that later. Okay? At the end of the day today, we're going to talk about things that you can do later. This will be one of those things you could come back and rework this. And in fact, it probably would be a good idea to, before you come back to the workshop on Thursday, is to actually come back on Wednesday afternoon and actually run through each of these notebooks one time, just to remember what you did. This is especially true if you've never done any coding before. All right? Now, one of the things that we can do with lists is we can slice them, okay? So the format is we have a variable of a list, we call it new list, we say equals, we take our original list name, and we tell it where to slice from, where to start, where to, pardon me, where to start, where to end. Now notice here that we're calling this new list. Python automatically knows it's going to be a list, not because I called it new list, but because I'm making it based on an existing list. All right. And so if I want, let's first of all, let's reset the substrate concentration list back to the original 13 values. That's what's going to happen in this line. And then I want to make a short list. I want to see substrate concentration 0 through 3. All right. So I just did that, but notice we've got no output here. So we don't know what happened. So let's take a look at it when we say print short list. So it prints the first, second, and third value. Now in Python, counting starts with 0. So 1.0 is actually the 0th element on this list. 2.0 is the first element. 3.0 is the second element. And when I say the substrate list should be 0:3, that means it goes up to 3, but does not include 3. So it's not inclusive. So it just includes those first 3 elements, but it's actually elements 0, 1, and 2. So substrate concentration 0, 1, and 2 appear here, but not 3. That's confusing, but that's the way it works, okay? There's a check your understanding exercise here. We're also not going to do that right now. But I'm going to move down to for loops. And once again, I'd encourage you to come back and do that with the check your understanding. You can click to see the answer there. It would be a good thing to look at and just to run these exercises and see what you get. So for loops are a tool, not just in Python. I've used several other coding languages in my previous life, and they all have for loops, okay? And a for loop enables you to do repeated calculations. So a for loop, the syntax in Python is for variable in list, then a colon, and then when you hit return after the colon, it automatically indents it 4 spaces, and then it does things to that variable, all right? So for example, here we have our list of substrate concentrations. We've already done that. And so what we're going to say is for number in substrate concentrations. So for a variable in a list. We're going to say velocity equals, this is just the Michaelis-Menten equation. We're going to tell it to print the velocity. Whoops, didn't mean to do that. So just going to hit the run button, and you can see that it calculated velocity values. Okay, and this gives us our values from our lowest to our highest substrate concentration. All right, so we can also add new things to a list and do different things with a list. All right, so what I want to do is I actually want to create a new list called velocities. So instead of having these print up separately, I want to create a new list that I can use for some future issue. So I've got, once again, I've got my substrate concentrations. I don't really need to declare that again, but I did. So I'm going to use the same function. So for number in substrate concentrations, I calculate the velocities. Then I say velocities dot append, and then in parentheses v. So I'm going to add the value of v to the list called velocities. So I go ahead and run that, and I get an error message. Now this is actually an error I did on purpose. Okay. And when you see it, when I see an error message in Python, I'm hardly an expert at Python, but I know enough to go to the very end and see if there's something in that last statement that I can understand, because there's going to be a lot of stuff up here that I may not understand. All right. So it says name velocities is not defined. So that's a list it doesn't know. Now, notice here there's also an explain error button. And I can click that button and it will send it over to Gemini, and Gemini is going to give me a detailed answer that's probably not too much different from this answer. All right, so it says the means that you're trying to use the variable before it's been created, okay? And I find that handy. I quite often ask Gemini to explain what happened in a cell. So what I'm going to do here now is declare a list, velocities. Now the square brackets, that tells Python this is a list, all right? Doesn't have anything in it. It's an empty list, but it's still a list. That's the kind of variable it is. So here are my substrate concentrations. I'm going to go through that loop, and I'm going to append the value of V for each of these substrate concentrations, and then I'm going to print out the velocities. And you can see now, now I have a list. Notice it opens and closes with a square bracket, and that list contains the values for the velocity at the different substrate concentrations. Okay. And okay, I think I am going to give you 2 minutes to work on this one. Okay, so write a loop that prints every value of velocity on its own line. So I'll give you 2 minutes to grind that out. And here's my first hint. Never write code that you can copy, okay? So there's some code here. Let's copy this code, put it in here, and see what we can get, see how we can modify this code to make it do what we want. I'm seeing a few questions in the question and answer window. Please take advantage of that. All right, so I'll show you a couple things we can do here. So if I put this print velocity statement inside the loop, so actually, let me undo that. So what I'm going to do is I'm going to backspace. I'm just using the delete button here on my Mac. I'm going to backspace and then hit return. And now notice that print velocities is inside the loop. And if I do that, then what it does is it prints the list every time it goes through the loop. So there's actually 13 entries there. So I don't want to print the whole list. I just want to print the velocity as it comes out. So I just put in print v, and it gives me each value on a separate line. Now, you could also say, well, we could go back up here. We already did it with this. Well, that's true. Okay. Right, so that's a for loop. Another thing we use a lot in Python are logic statements. Okay, and logic statements are like if, I mean, logical, if you took a philosophy course where they talked about logic, you learned about if-then statements. A lot of what happens in Python is if, then, else, things like that. So we're looking for ways to compare things. And so in our first cell here, I'm just going to set a value of temperature is equal to 35. Okay, so that's just the number we want to check. Okay, and then I have a logic statement. If temperature is greater than 30, now notice there's a colon after it. All right, so actually I'm going to show you this as I type it. So I'm going to say if temp greater than 30, if I put a colon and hit a return, notice it automatically indents. All right. And let's say I want to run that code. I don't want to erase this code. I just want to keep it there. I'm just going to put a pound sign in front of it and hang on to it. And maybe I'll come back to it later. All right. So I'll run this and it says, oh, it's hot. Now, if you go back and I've got temperature assigned here is 30, let's say it's 25, you run it, doesn't give anything, doesn't give an answer. All right. And I should have practiced this. I think if I put an elif in there, then you know what? I'm gonna take a risk. Maybe one of you guys. So I put in elif, and it puts in temp less than 10, print cold. Else, print okay. So we've got if, elif, and else as the three options. Okay, notice that each of these is followed by a colon. So we put the temperature in, it's 25, get a value of, okay, what happened? I think, okay, that wasn't indented. That wasn't indented. Now it should work. No, it doesn't like that either. All right, well, I'm not going to make any more mistakes publicly here, but I know there's a solution to that. I just don't have it right offhand. But we're going to look at a few cases here. So here's a case where we've got something you can do in Python is you can assign more than one variable in a single line. So I have two variables, km and vmax. I say equals 15.0, comma 100.0. So that assigns the value of 15.0 to km and the value of 100.0 to vmax. And then I declare a new list, linear underscore mm. So this is the linear portion of the Michaelis-Menten curve. I've got my substrate concentration list there again. And so I'm setting up a loop saying for the number in substrate concentrations, if that number is less than 1/4 of the km value, then I'm going to calculate a velocity for the linear portion of the Michaelis-Menten curve, and I'm going to append the value to the list called v linear. So when I do that, I get this. And so the first three concentrations are less than 1/4 of the km. The km is 15, so 1/4 of that's going to be 3 1/4. And the question is, do you need the 0.0 in the variables for significant figures or other formatting? I have the 0.0 there to make sure that it's a floating point number. Okay, so that doesn't assign significant figures, but it does tell Python that that's a floating point number. Now, for these comparisons, there are other things you can use besides less than. You can use greater than. You can use equal to. That's two equal signs. So if you're comparing two numbers, typically two variables, to see if they have the same value, you use equals. Or if you want to make sure they're not equal to each other, then you have this pound equals, or a pound, not pound, exclamation point equals that tells it not equal. We have greater than or equal to, less than or equal to, and we can also use and, or, and not. Okay? So velocity at or below the km value. So that's a new list I've made. So for number in substrate concentrations, I'm going to do a question here. If the number is less than the km or the number is equal to the km, then do the calculations and come up with the values and create a list or print the list up at the end. Now notice here that the name or is shown in blue. Okay, I think it's blue. Anyway, that means you can't declare a variable and call it or in Python. There are reserved words. Likewise, for, in, if, those are all different colors. You can't use those to be variables. Okay? So if I run that, once again, I get our list, and the list goes up to a value of 50, which is, that's when the concentration is 15, which is the km. And not surprisingly, the maximum velocity we see on that list is half Vmax, which is by definition what km is. Okay, I'm just checking to see what else is on this notebook, and I'm looking at the time. Okay, I think the rest of this stuff, I'm going to let you do on your own, but this is a simple if statement here. And then at the end, there's an exercise here. At the end, there's some links here. Here are 3 different links. One is the home of Python. So that's where the Python community contributes to this open source tool, Python. Problem Solving with Python is a free textbook written by a community college professor in California. And it's very nice. You can get the book with problems in the back. Very powerful stuff. It's free. You can also order a copy of it from Amazon if you want to have a hard copy. Corey Schaefer's done some marvelous tutorials on Python, all things Python. And I would encourage you, if you want to learn a lot more there, you can do that. There's some challenges here at the end. I would encourage you to do these before we meet on Thursday. And so there's 3 different challenge questions here. And I encourage you to start to work on that. And at this point, we're going to take a break. And once again, now is a time when we're going to be open to answer questions. If you have questions, stick around. I'm going to go into the participation or participants and unmute you so you can ask questions. You can still put questions in the chat. You can put questions in the Q&A window. And Wally, in the chat window, Wally put a correction for the thing I couldn't get to work earlier today. The if statement I fiddled with, it didn't work quite right.
It's hard when you're under pressure like that.
It is. So print hot. Oh, then elif should be spaced back.
Yes.
And cold. And then else is spaced back. And print is spaced back. All right. And now it works. So I put in minus 273. There's 271. Cold, indeed. Any other questions while we're on break? I encourage you to get a drink of water, take a bio break if you need to, whatever. We'll be starting back up at 3:15. Chris is going to take us through an exercise with pandas and plotting.
Oh, there we go. All right, so I'm going to come down here, and we have this cell at the beginning of a lot of our notebooks because it's a useful reminder of how to run it. When I'm teaching with students, I have this in most of my notebooks, either some phrase like this or this exact code or the exact text block itself, because we always forget where the play button is. So I'm going to come down here and we're going to import the libraries. So I'm going to click on the play button. Now, I wasn't connected to a runtime, but I will be. And while that's connecting, I'm going to come over here to the down arrow and go to manage sessions because I have a feeling I've got another Colab running in the background and I may want to turn that off. So I've got an unknown notebook. I'm just gonna, oh, that's the one I was running earlier. I'm gonna close that one out. Colab and Google tend to get a little annoyed if you have multiple Colab sessions running at once. So I'm going to close out all the Colab sessions except for the one that says current session, and we'll be good to go. And I've imported several different libraries here. NumPy and Pandas, the one will be the main topic of interest today, and then Matplotlib and Seaborn, which are ways to plot your data. And then I have some styling things here to make the plots look a specific way. Realistically, you could do most of this notebook with just the Pandas part, but the other ones there are useful for some of the later sections, which we may or may not have time for, as well as the challenge sections at the very bottom of this notebook. Now, in Paul's notebook, he had you working with lists. And a reminder, a list are these numbers here in the sequence found inside the brackets, and then we gave it a name, substrate concentration. So we assigned this list of numbers to substrate concentration, and we assigned our key values using Km equals or Vmax equals. I push that. I've now assigned those. And if I run this code, which will create an empty list called velocities, and then run through substrate concentrations and do the Michaelis-Menten calculations on it and print it out, we get the list of numbers that ran through that calculation. So we did this in the previous Colab, but this is, as far as we know, how we're working with data. And again, these two types of velocities and substrate concentrations are list type values, but we don't, right now they're separate. So substrate concentrations is independent of velocities, but that's not necessarily how we always work with the data. There are a couple of ways where we could put these two together. One is something that is called a tuple, which is a Python specific thing, but is immutable, meaning it is data set that are linked and keeps the data pairs together, but it doesn't allow you to edit or do any sorts of additions on it. The way we're going to work with data today is in a data frame, which is more akin to an Excel spreadsheet, where you could have a couple columns of data, and then you could do some math with those data, create a new column, and then do other work, or you could filter out certain data or something like that. So what we can do is take our lists that we've got, substrate cons and velocities, and give them a name inside these curly braces, inside the parentheses, inside PD, which is our call for pandas, data frame. And then we're going to call it something called data frame. And then I'm going to print out the data frame. And when I do it, it's in the two column format that we are very comfortable with when we think about enzyme kinetics data, or sometimes like the outputs from your instrumentation. You might have wavelength and absorbance or something else. So data frames are very powerful and very useful because that's how we think about data. And so let's explore data frames in more details. Now we're going to create a synthetic data frame, and it's going to have the columns that are listed in this table here. Some of these are categorical, meaning it's ABC, in this case, in terms of the species. A lot of these are going to be numerical, and we're going to go and sort down through them. Now, I'm not going to show you how to create the data set. We're going to push a button. But if you want to see the code, you can click Show Code, and you can go down through all the things that had to be written to make the code happen. But I'm going to hide it for now, just for simplicity's sake. So I have a data set that's got 9 columns and 200 rows of data within each of those 9 columns. So you've got your file, but we don't know what it looks like. You can't see how it's structured, you don't see how it's organized, and being a visual person, I like to do that. So there are a couple of ways using pandas that we can look at the first 5 or so rows, or look at the bottom rows, or get the shape of the data frame. And those are the commands listed here. The name DF is something that will change. Now, I use DF for data frame because it makes sense for me, but you might call it kinetics or something else. Whatever the name of your data frame is, will go first, followed by a period, and then the command. Now, some of these commands have parentheses and some do not, so be careful when you're doing that to either include the parentheses or not. And this will allow us to look at our data frame. So in these code cells below, I think there are 4 of them. I've given you tasks as comments. So in this first one, I want you to show the head, which is the very top of the data frame. The next one, I want you to list the column names. The third one, I want you to look at the data types. And then the fourth one, I want you to print the info. Now, the basic command is here in this table. You're just going to try to put it in the right spot and follow directions. So I'll give you a moment to try that. And then we'll come back together and do it. Now, again, if you have questions or issues, hop in the Q&A or in the chat, and we will help out. All right, so we're going to look at the top of the data frame. We're going to use head, and I only want to look at the first 5 rows, so I'll type head, and then have 5 in parentheses. That defines the number of rows, and run it, and it gives us the first 5 rows. If I want to do the first 11 rows, I can change the number here, and it'll print out the first 11 rows. Now you'll notice these buttons down here that appeared. Colab knows you're working in Pandas, and so it will help you and prompt you to create interactive sheets, or you can help you generate code. We'll explore more with this on Thursday, but this is an option to help you, especially if you're new to data analysis. All right, I'm going to do columns here and see how it's running. And so then gives me the list of columns and then data types. I'm going to type this. And I don't know if you all can see, but as I'm starting to type, it brings up this submenu, which gives me the rest of the command. You can do tab and it will autocomplete for you. So some of what Paul showed you was using the AI. What's showing up here is it's giving me the potential options for it, and you can explore those menus. So I'm going to run this, and it tells me the different data types. I've got some integers, I've got some objects, I've got some floats. So we've got different data in different columns. And then the last one is info, and I believe info needs parentheses. And we'll do that. And there we go. Now it runs. And so it tells me the column name. It tells me how many of the values in that particular column are non-null, meaning it's not blank, which in Python they code as an NA. And then it tells me the data type. So this is a good first look at not only what your data look like in terms of how it's organized within the spreadsheet. It also gives you a sense of the type of data that you have, and then the number of non-nulls that you might have in your particular data frame. Your non-null count, your NAs might be a little different than mine, but overall you should have 200 data points in most of the columns. So, all right, so something pop up here. Take a look at the Q&A. Why does .info need parentheses? That is a great question that I do not know the answer to. I would have to look it up myself, but I will look it up during the next break and see if I can give you some more information on that. So yeah, great question. Why does that particular one need parentheses? I'll look it up for you. All right. So far we've loaded our data in and we've taken a preview of what the data look like. Now we want to take a look at and do some math on them. And there are 2 packages that are frequently used for this exploratory type of data analysis. Pandas, the one we're going to use, and then NumPy, which you've heard us talk a little bit about. I've got an exercise with NumPy at the very end if you want to explore that. Some people really prefer that over Pandas. I use whatever works. I tend to be a little more pragmatic with it. Now, the way that they structure these commands are very similar to what we saw up top, where you do the name of the data frame, in this case, df, dot, and whatever the command is. And in this case, all of them, except for describe, require parentheses. So we will have those parentheses in there. So if we want to calculate the mean values of the data frame, we can do that, and we're going to get an error. And it tells me that the error is the string of letters. It cannot convert that to numbers or numeric. Well, that makes sense. We can't turn around and take the alphabet and make it into numbers. So if you try to do this and you have mixed types of data, or you have categorical data or something, it will give you an error. And so what we need to do is go in there and find another method to preview this, which we're going to use in the describe function, or we need to look at it column by column, which we can do in just a moment as well. So first, let's explore describe. So here's describe. Oh, and it works. And here we go. So it tells us the count, and then it gives us the mean, the standard deviation, the min, the quartile ranges, and then the max. Now, there are 8 columns here. We had 9 in our data frame. The one it's not including is the one that had the categorical data. So it's not including the ABC one that tells us about the species. So describe will only work on the numerical data frames. And this button popped up here to the right. You can push on this and it will allow you to explore the data in a little more detail as well. All right, so we've described our data frame. We know the values. And we had some issues where we couldn't do some of the statistics, or maybe we want to describe values, but we don't want to look at all of them. We only want to look at a single column. So in this case, we're going to break it down such that we identify the column inside brackets and inside quotes, and then we have it structured just the same way as we did for our data frame, where we do dot mean with parentheses after it. So if we try to do it for the species column, we know this is going to fail, but we're going to do it anyways just to prove it to ourselves. We try to do it on the species column, it fails because it gives us the same error. But if we try to do it on a different column, we get the value that we expect, and it's inside this NP float. So in this box, let's do this with describe, and do describe on just a single column. It should work the same way as we saw previously, where we get all the values. And that's what we get when we get the different statistics for the column itself. So why don't you all take a moment and try to calculate the mean value for the mill column, the water mill column in the data frame. And if you need to remember how that column is indicated, you can come up here to one of the previous boxes and it gives you the name of the column, and make sure you type that in. It is sensitive to the case, so you can't throw in a capital, and you have to include that underscore in there. So give everyone a moment to work on that, and then we'll all check it together. All right, so I'm going to highlight the underscore. I'm going to put my brackets in, and then I'm going to type water and mill and run it, and it gives me the value, and it says what type of data it is. It's a float, and then it gives me a long string or a long series of numbers. Now, if I didn't want this leading edge part where it says np.float and all of that, I can put it inside a print command. And when I do that, I just get the number. So if you want to get what type of data it is, you can just call the value that you want. But if you put inside the print command, it will just give you the result of that particular calculation. And that can be useful, especially if you're trying to do, if you're going to be want to just print out a clean number or something like that. So let's try doing an F printing. Let's combine Colab 2 and Colab 3 and see if we can make it work. So we're going to print out a statement that tells us what our mean value is. So our mean value of water is 246.47, blah, blah, blah numbers. Let's say print, and then we'll do our F, get our quotes in there, and we'll say, oh wait, I need the braces, don't I? We want to say the average value of water was I'm 100% forgetting how to do F print statements right now. Oh, I know what it is. I'm missing that, aren't I? There we go. Paul, you're gonna have to help me out. I'm probably gonna forget how to do this again. All right, then we got our call, we got our mean.
You don't need the curly bracket before the V. You need curly brackets around the variable.
Thank you, Paul.
And I probably left something out there, but
I think that closes it out. And we'll include the period, and there we go. So the average value of water was 246. Oh, it does have units on it. I want to add units on it because then it looks correct to a chemist like me. All right, there we go. So while a fairly nondescript statement, we've now got our value in there, and it's a big number in terms of it has a lot of decimal places. And in a few moments, I'll show you how we can reduce the number of decimal places in there to do something that is always bothering me, significant figures, and trying to make sure that the significant figures are correct. So, all right, so we've got our F statement. Now, say you want to look at a number of numerical columns. You don't want to do just one column. You don't want to do the whole data frame. Well, you can create a list of the numeric columns that you're interested in, or the columns that you're interested in for that matter. And that's what I'm doing here in line 2. And then I can go through and create a new data frame out of those particular columns. And what I can say is from this new data frame, the column mean will go through and it'll calculate for all of those columns the mean value for median, and then the standard deviation, it'll calculate the standard deviation. So I'm doing 3 different calls and putting them in new columns in a new data frame. And I'm going to call that data frame stats, and then I'm going to print it out down here. So we've got our stats. And so on the left side, I've got my column name, or sorry, my variable name. I've got the mean, median, and standard deviation value for all of that. And again, we've got a lot of decimal places in there. As someone who teaches Gen Chem a lot, I want to reduce that down and get the sig figs right. So there's something called round that you can use, and you can reduce the number of decimal places. So I'm going to go in and type in round after a period. And then I'm going to say, I just want to do it to 1 decimal place in this case. And then when I run that again, I've now got all my numbers down to 1 decimal place. And so this is really nice in simplifying the number of the length of the numbers that you see, but also trying to bring them in line with what you'd want in terms of describing the data correctly. All right. And I believe you could also call round up here. So let's try that. We'll do round after mean. So we're doing mean dot, doing the columns dot mean dot round. And let's say we'll do it to 2 decimal places. And yep, there it works. So you can stack these commands on top of each other and have them work out either when you're calling the data frame, or you can do it afterwards if you want to do it to the entire data frame as a whole. So you could go in and customize in each of these calculations where you're doing that rounding and to what level you're doing the rounding, which would be important for certain data types. All right. And sometimes we want to group things together. And so in our data frame, we've got 3 different species of plant, and maybe we want to analyze between the different species how much water they were given, or how much sunlight, or how tall they grew, because we want to do interspecies comparisons. There's something called group by, and it's a little complex at first to work out how to structure the command. So I've broken it down here. All 4 of these bullet points are effectively one call here on the screen. So what you have to do is you set up your variable assignment, and you say data frame, group by, and then you say in parentheses which particular variable you want to group by. Species is the logical one in terms of being categorical. And then you want to indicate which variables, which columns you want to then compare, and then how you do the comparison in that aggregate. So I'm going to aggregate height and leaf count, and I'm going to look at the mean, median, standard deviation, and the number that are in each group, and then I'm going to round everything to 3 decimal places. And then I'm going to print it out. And there we go. So I have my species A, B, and C, and then for height in centimeters and in leaf count, I've got my statistics, my 4 columns of statistics for each one. This is a very easy way to do some pretty complex comparisons in spreadsheets. As an educator, I will not use Colab to do the grading, but this is a way that you can go in and start comparing between grading groups and things like that as well. So you can use this a lot of different ways to look at comparisons between groups and get a sense of how the statistics are within your spreadsheet. Python is pretty good at dealing with very large data sets. So this happens fairly quick. All right. Looking at the numbers are great, but sometimes you also want a visual of it. Histograms are pretty popular. So we can generate histograms. Now, the way it's going to call right now, I'm doing the entire data frame, and we're going to look at the histograms for each of the numerical columns and print those out. So I do that, and it produces a histogram for each particular data set. There are different types of plots you can do in Pandas, and I can put this link in the chat later. But there are, where was it? I had that list. You can do bar plots, histograms, box plots, density plots, area plots, a lot of different things for exploratory data analysis. We could also alter this to do only one of the variables. Maybe we want to do water in milliliters only. And so I do what I've done previously, where I bring out the brackets and then put the column name in quotes. I do that, and I get just one single plot. Now, it is missing labels and all the things you might expect from your students, or if we were going to publish this. And we will have to do a later session on how to do plot customization and all of that. But this gives you at least a introduction to the types of plots you can pull out of Pandas using the basic commands. All right. So far, we've really dug into the numerical variables quite a lot. There also are the categorical variables. A lot of times you're just looking at the numbers of each categorical variable that you have and doing comparisons that way. The command for that to count up the number that fall into A, B, or C is value counts. And so I'm going to set this up as we've done before with data frame, the df, and then the brackets and the column I want in quotes, dot value counts, and assign it to something called species count, and then print it out. And it tells me that there are 80 in B, 65 in A, and 55 in C. And that would be the main way to compare categorical variables, at least at this level. You could do some further analysis with some more complex commands. And the last thing we're probably going to get to is making new columns from existing data. I mean, so far I've shown you something that you could do with an Excel spreadsheet, and it wouldn't take too long to do that, but it's not, a huge advantage. Why would you want to start doing this in code? Well, that's where Python is really good, and especially good at large data sets, where in Excel trying to drag a formula down or something like that might be pretty difficult. Python will do it very quickly. And the way we make a new column is you name the column in the data frame. So I'm going to do something called height per leaf equals, and then I'm going to do the math. And the variables I'm going to use are the names of the columns in the data frame. So in this case, I'm going to divide the height by the leaf count. And then in line 6, I'm going to indicate which variables I want to print out so I can do that comparison. So I'm going to do height, leaf count, and then I'm going to show my new variable, leaf. And then I'm going to print out just those columns and just show the top 5 rows. So when I run that, I get my height per leaf. Now you'll notice again, my numbers have a lot of decimal places in there. You could go in and round that if you wanted to. You can set it to, and it will simplify the data for you and print it out. One thing to point out when you're doing this rounding, because I'm doing it here in the print statement, I'm not actually changing the underlying data. If I wanted to change the underlying data, I'd have to do it up here when I originally did the math. Okay. Let's see. We're running just a little bit short on time. So here's what I'm going to do. I'm going to encourage you all to try to make 2 new columns on your own during the break time between the sessions today and then on Thursday. And if you are struggling with that, we can help you with that on Thursday as well. Because I want to show you one last way to work with your data, and that is called binning. And what this allows you to do is to take a numerical column, in this case light hours, and then create a series of bins to create a categorical variable, effectively, where you're taking the numbers and you're saying, well, if it's between 0 and 7, that's low light. Between 7 and 11, it's medium light. Between 11 and 15, it is high light. And you create a new column that way. So you run that, and it shows you that depending on the light hours, you get the different categories here. You can see all 3 different new categories are represented. This is a fun way to efficiently go from numbers to letters or something like that. And I will run a local version of Jupyter, of Python on my computer. And this is how I assign grades. I just create the bins and have the code run through my gradebook, and it creates the grades for me automatically. And it saves me so much time overall. So it is a nice way to take your numbers and put them into areas that are easier to read overall. One last thing to look at will be importing and exporting data frames. You can read CSV files or write CSV files. And when we're thinking about Excel, typically you're either working with an Excel file or something called a CSV, which is comma separated value. Comma separated values tend to be smaller, and it tends to be more useful. So I typically only work in CSVs, even when I'm working with students. I only use the Excel format when I have to. In addition to those 2 file types, you can also use a lot of these others. But I imagine most of us work in either CSV or Excel. If you get data from an instrument, a lot of times it's in a text file, and it's fairly straightforward to convert text to CSV and to do that as well. So it's not too bad. In terms of importing, you can do just like what we have seen previously, where you have the link to your file and you can read that CSV. And then if we wanted to, we could then look at the first 4 rows of that particular data frame. So I'm going to import the data from GitHub. And then hopefully it'll print it out for me. And you can do all the things that you would want to do. You could do describe if you wanted to on this, and get the values. So I just use the link from GitHub and you can port it that way. You also have Google Drive. If you had it in Google Drive, you would give the file path. Just like we've got the internet link here, you'd get the file path, which in the Colab, the very first Colab, I show you how to structure the Google Drive variables to set it that way. Or you could have it here locally in the folder and just give the file name here as well. So a bunch of different ways you could read the CSV to bring it in and then bring it up as a table and then go from there. And then if you want to save it, you would give the name. So let's do species summary actually. And say we're going to convert it to CSV, and then we're going to call it summary.csv. Or actually, let's see, what did I say to do in the exercise? Species underscore data frame. There we go. So if I run that, I didn't tell it where to put the file, but when you just run it like this on the desktop, it puts it right here in your file folder, and then you can push the 3 dots and you can download it or rename it or whatever you want it to do. So if you don't have it connected to Google Drive or you don't say it's going to somewhere else, it will just drop it here in this files area and you will have to then download it, because once you disconnect from the Colab, all of your data disappear. So unlike Google Drive where things get saved as you're working, with a Colab, while you're working and while you're connected, it'll be saved. But unless you save it before you close out the tab or end the session, you will lose all of your data. So if you saved anything to the local files, you want to make sure that you download that before you disconnect from the Colab and lose everything. So I think I have hit my time, so I'm going to stop. And I believe there are some final remarks before we end today.
A couple things, Chris, if you could share your screen again.
Yeah.
I just want people to see some of the power here. If just double click on species data frame.csv.
Yeah.
See
Oh,
that?
yeah, it shows it here in the preview on the right.
And that gives you the preview of the file. So you get to see that, which I use that quite a bit. Another thing, there was a question earlier about why does df.info have parentheses and df.dtype not? Okay. The reason I looked it up, and the reason is that info is a method. So it actually goes in and it does some calculations based on what's in the columns or what's in the cells. Dtype is an attribute. So it can just go in there and say, oh, that's an int. Oh, that's a string. And so if it's a method, if it does some function on the content of a cell or a column or parts of the data frame, then it has parentheses. But if it's just an attribute, it doesn't.
Fantastic. Thanks, Paul.
You bet. You bet. All right. That was great, Chris. Excellent job all around. Let me go back to my opening PowerPoint. I'm going to share my screen again. We're still recording. And once again, this recording will be posted at some point. I'm not sure how quick we can get it up there. All right. So this is what we did today. And why can't I get it to advance? Okay. So on Thursday, we're going to do a recap and common questions. So what would really help us is, I'm sure you have questions. If you could email those questions to coding4bmb@gmail.com, we'll take a look at those before the session on Thursday. And probably, I expect there'll be quite a number of common questions that show up, and we'll group those questions and answer those in that opening session, to the extent we can without using up the whole period. Also, before Thursday, I'd encourage you to spend an hour or two between now and 1 o'clock on Thursday, we're actually just running through and reviewing the stuff we did today. Just to remember, oh, that's right, that's what a data frame is. That's why, that's why there's a period followed by a round with parentheses. That's why there's this, that's why we do that. That's what an F-print statement looks like. Because what will happen on Thursday is we'll continue covering material the same way we are now, but we might get a little careless and assume things that you don't remember. And so if you practice a little before then, I think you'll find that very helpful. And also there are exercises at the end of the notebooks that you can do that would be good practice. And anything you do is the practice, even if it breaks. In fact, it's better if it breaks. If you go in and break it, then you'll fix it. At least for me, if I make an error, then I have to go and fix it, then I understand what I did. If I get, by dumb luck, if I get it right the first time, I assume I know what the answer is. I don't really, half the time I don't really know. I just got lucky. And so that's something to keep in mind. All right, other things. So we got 4 different projects you can work on Thursday. And I'll talk about those in a minute, but I'll present those, review those again there. Then Wally's going to spend about half an hour taking us through a notebook about linear regression. And then Chris is going to lead a session for 45 minutes about talking about using Gemini to modify code. And that's a really important skill because I doubt that any of us are going to become full-time coders. And in fact, if I'm not looking at code for a week, I forget almost everything I used to know. Okay, and that I think it runs out of my brain faster than it used to, but it goes away pretty quickly. And AI will bring you back and help you with that stuff. It's not automatic; it doesn't always get it right, but there are helpful suggestions in there, and Chris is gonna show a number of approaches to doing that. I'm looking forward to that session. I learn stuff every time Chris makes a presentation. Then at 2:50, we're going to ask you to select a project. Mike Foster is going to be hosting a breakout room called Colab and Python Basics. And so if you feel like things are moving a bit too quickly for you, and you're just getting started, or you've been away from coding for a long time, that'd be a great place to be. And he'll be going over stuff and answering all your questions. I'm putting you on the spot there, Mike. Good luck. Then we'll have 3 other rooms where we're looking at the protein assay and linear regression, which is something Wally's going to cover at 1:20, but going into more depth with that. We'll be looking at nonlinear regression and enzyme kinetics, and I'll be in that room at least some of the time. And then finally, there's a sequence analysis that Wally's going to be leading, where you use BioPython to pull some sequences, to group them, to do some interesting things with those. And then what we're going to ask people to do, so you'll have 35 minutes to work on that. And we're actually going to ask people to come back and share what happened in those rooms. And we want honest sharing. Did it work? Did it not work? What happened there? What was missing? What would have been better preparation for that process? All of that, any feedback we get here is very, very valuable to us. And also, that's pointing us toward our teaching with code theme that we're going to be doing in workshop set 3. And because learning to share about what you've done and explain the code that you've written and the results you've gotten is a big part of teaching with code. All right. Once again, the post-workshop survey is happening on Thursday, and so we'll have that for you then. And here are our links. And once the workshop is over, we'll provide this file. In fact, I'll put it after I'm done chatting. I'll put it into the chat room. I'll put a link to the file in there, and you can just download it now if you want. Again, a review. We'll be doing a workshop at the Biennial Conference on Chemical Education on July 26th, on that Sunday. And it's a 3-session. There's 3 1.5-hour sessions that we'll be doing there. Much of what we'll be doing there is similar to what we're doing today. And that might be a very useful thing, because it will have been a month and a half since you looked at this stuff. Or 2.5 months, I guess. Anyway, that's going to be happening. We're planning a learning to code workshop for the fall, where we'll be looking at more notebooks in greater depth. And in fact, I was going to suggest, Chris, that if you wanted to create a grading notebook I think the people in the audience here would be very excited to have that in their hands. I think we would learn a lot more about Python coding because we'd have to use that every semester. And then third set of workshops is planned for spring of 2027, and our goal is that you participate in all 3 workshops. We really want to make that happen for you and for the project. And keep in mind that our goal also is that you're going to start producing Colab notebooks that you're using with your classes and sharing those with us, and they'll go through a vetting process where you turn them in, and members of our community, our small community, will look at those and say, oh, this works, oh, this doesn't work, and talk about ways to make it work better. Once again, thanks to the people that supported us. And I think that's it for today. Any other comments from Mike, Chris, or Wally? All right, I'm going to go in the chat room and I'm going to grab that PowerPoint file and I'm going to drop it right here. First, I have to figure out where it is. Ah, it's on the desktop. That'll be easy to find, I think. Okay, you should be able to download it now. And we would also very much welcome anybody who wants to be in our Slack community. Let us know, we'll invite you. You can also go to our LinkedIn page. And if you go there and ask to join, once you get accepted, if you could just give us 25, 50 words about who you are, what you're doing, what you're learning, that would be very welcome. And you can send us any questions for Thursday to that codingforbmb@gmail.com email address. And that's on the bottom of each of the slides in the slide deck I just shared. I won't close the window. I'm going to turn off the recording now, but I won't close the window for another 10 minutes if people want to stick around and ask any questions.